Hello, I'm Eddie Ramirez, VP of Marketing for the infrastructure line of business at Arm. Today's webinar, we're going to walk through the Carbon Intelligent Cloud running on Arm and the advantages that Arm-based cloud instances can provide to developers across the world. Advantages such as reduced cost, improved TCO, performance acceleration, as well as sustainability. This is part one of a two-part webinar. The first part is really an introduction of Arm and those advantages that I spoke of. And the second part will be a more technical deep dive for developers and IT people on how to actually migrate those workloads onto an Arm-based infrastructure. Let's get started. The agenda is quite simple. First, I want to introduce you to who is Arm for those who aren't familiar. Then we'll talk about Arm Neoverse, the platform that is helping revolutionize cloud instance deployments across the globe. I'll walk through some of the portfolio options and some of the cloud providers that are utilizing Arm-based Neoverse compute. And then I'll talk about some of the lessons of partners who have been early adopters into the migration to Arm compute and what we're seeing in the workloads that they've migrated over. Let's get started. Arm is the world's leading semiconductor intellectual property supplier, with more than 500 silicon partners delivering solutions. Our partners combine Arm IP with their own IP to create complete chip designs. Our technologies securely power products from the smallest sensor to the world's smartphones and even out to the world's most powerful supercomputers. A key tenet of our architecture is energy efficiency. Energy-efficient processor designs and software have enabled advanced computing in over 190 billion chips since Arm's inception in 1990. We've now delivered over 29 billion Arm-based chips shipped since the end of 2021, and we're not stopping there. So what can Arm, and in particular, Arm Neoverse platform, do for you? The value proposition is very simple. It can help you with improved application performance. Across a broad set of workloads, we'll share some of these workloads with you today. We've seen Neoverse N1 CPUs outperform the latest generation of CPUs from other x86 offerings. It can also bring significantly cost reductions. Neoverse-based instances are generally priced at much lower for the same amount of computing resources compared to x86-based instances. And more importantly, it's a great way to meet your sustainability goals. Arm Neoverse brings leading-edge energy efficiency, which can drastically reduce your carbon footprint. These three are distinct benefits, but they typically combine to offer an even greater incentive to move to Arm. The good part is you have a lot of choices for how to access Arm-based compute instances in the cloud. Most notably, our partners like AWS have been delivering cloud-based instances on Arm for several generations now. But we also have new partners like Microsoft Azure, Google Cloud, Ali Cloud, the Oracle Cloud Infrastructure, who have all adopted Arm-based instances this year. And we're excited by all of the partners across the globe, whether it's in China, the US, or even local European operators like Hertzner and Scaleway, who are now offering Arm-based compute instances. AWS was the first cloud provider to offer Neoverse-based instances, as they are now on their third generation offering based on Graviton 3. Graviton 3 is the processor at the heart of the servers that offer these compute instances. The majority of AWS instances are currently based on Graviton 2 and the newly introduced Graviton 3. Since the time of AWS's support for Arm-based CPUs, they've now been able to migrate and offer a plethora of instance types, from general purpose compute optimized, memory optimized instances, storage optimized, and even instances that offer accelerated computing. These instances support anywhere from 100 gigabits of network bandwidth, the latest NVMe SSD storage, the latest DDR5 memory, all combining to offer 40% better price performance than traditional x86 offerings. You also see the benefit of 3.45x performance per watt, which in the overall picture results in a lower cost structure. The more energy efficient the processes are, the less energy they waste, the better cost savings are passed on to the end user. So the Arm-based instance deliver improved performance, price, and the sustainability benefits. And we'll only see that benefit increase with Graviton 3. Generation to generation, the new instance types that were released this year further push performance by 25%. And in particular, workloads like ML will see a significant boost of up to 3x performance. And we continue to provide all of this compute with a much less energy footprint. So whether you're using Graviton 2 or starting to look at ARM-based instances on Graviton 3, there is a lot to get excited about. Now, it's not just only the standard compute instances that AWS has migrated to ARM. There are also several internal services that have now relied on Graviton CPUs. This now increases the overall ecosystem of solutions that you can get from AWS that are all running on the ARM-based architecture. On the left, you can see the multitude of services that support Graviton. These include common flavors of database, both SQL and NoSQL, options for map, reduce, and search, containerization options that are supported, as well as low-code or serverless compute options like Lambda, which is predominantly now running on Graviton 2. And you can even get on-prem Outpost services on Graviton today. So along with all of these internal services, there's a wide spectrum of software that runs on these instance types. And the ecosystem continues to grow thanks to Amazon's Graviton Ready ISV program. Alongside this growth in instance types, AWS services, and third-party ISV options, you are now seeing more and more customers making the switch. Across the spectrum, customers in social media, media and entertainment, digital advertising, design engineering, finance, technology, and consumer services are all making the change to Graviton and seeing great results. We were very excited to see Amazon announce that 48 of their top 50 EC2 customers by usage are drawing on AWS ARM-based Graviton 2 chips, just showing how the ecosystem maturity is there for customers to easily make the switch. Now, I want to talk about another partner, OCI. Oracle's has been deploying Ampere Ultra 80-core CPUs in their cloud environment, offering a total of 160 ARM N1 cores per server. These systems are state-of-the-art, including 1 terabyte of memory and 2 by 50 gigabits per second networking. Powerful servers that allow the customer flexibility to enable the right size of VMs to meet their needs. The advantage of a dedicated core per thread model that Arm Neoverse provides is that it enables predictable performance. So you can scale between 1 to 160 cores and have that scaling be very linear and not be degraded by how other threads are taxing system resources. There's also a benefit to security by not having multiple threads running on a single core. You're not exposing potential code sharing thread issues. Best of all, the price performance of these instances is just super compelling. OCI was the first to offer a penny per core hour rates for their ARM-based compute instances. Now, a third partner that I'd like to highlight is Microsoft Azure. This year, Azure VMs based on Ampere Altra ARM CPUs were made available to the general public. Their DPSv5 VM series, designed to run general-purpose Linux workloads, such as web servers, application servers, open source databases, and even .NET applications or Java applications, are now available in public preview. All of these support the major Linux OSs, including Canonical's Ubuntu, CentOS, RHEL, SUSE, Debian. So you now can see that there's a wide variety of operating systems that you can land on these instance types. More importantly, today, Microsoft announced .NET 7, which added several optimizations to the .NET infrastructure to improve the performance for ARM-based computing. And finally, the totally free Visual Studio Code Editor runs natively on ARM, allowing you to harness the power of the cloud for both your production and development environments. Learn more by going to the links shown here. The last partner that I'll call out is Google Cloud. Google Cloud is the most recent public cloud to offer Arm Neoverse-based VMs, introduced in their Tau T2A VM series in July. Tau T2A VMs are also based on the Ampere Altra CPU and support up to 48 vCPUs per instance. Google's ARM-based instances come with leading Linux distribution support, Google's container-optimized OS, along with the support of major database and programming languages. As you would expect from Google, these Tau 2A VMs enjoy Kubernetes GKE support right from the start. This includes support for both ARM only and ARM and x86 multi-architecture clusters. GKE customers can make use of popular features like autopilot and GKE data plane v2 networking. And there is support for VM pricing at launch. So you can have the ability of helping to save costs and maintain a fault-tolerant network. In addition, Google has enabled robust ISV ecosystem with leading tools from DevOps, security and observability, and partners such as Datadog, Dynatrace, Splunk, and Palo Alto Networks all have software that runs seamlessly on these compute instances. So where does that get us? That gets us to being able to offer a multi-cloud environment for running ARM workloads. And it also helps us drive the price performance leadership in the cloud. What I show here is a graph of the top 3 cloud providers comparing their cost per performance metrics using Intel, AMD, and ARM-based instances. And lower is always better when it comes to cost. And what we see here is that in this case, all 3 cloud providers, when you're looking at price performance leadership, are all offering 40% or higher improvement in price performance. Very significant, as ARM has been able to reset the power performance cost profile in the cloud. Now, a lot of folks want to say, what does this look like when it comes to actual workloads? What is that performance benefit? Because the previous chart was using SpecInt synthetic workloads. So now I want to dive into a few of these workloads that are very common for developers utilizing the public cloud. And what you'll see is that we've published several white papers for each of these workloads on ARM's community website. And the link is here for those who want to reference those. I won't go through these one by one, but you can see that some very common use cloud-native applications can run on Arm Neoverse with excellent benefits on performance per dollar basis. You have Redis, Cassandra, Memcached, Kafka, Spark, and etc., all offering double-digit improved performance over x86 or improved price performance over x86 instance types. And this is just a subset of the applications we've tested. To see more results, we encourage you to check out the Arm Neoverse infrastructure blog. Now, one of the ways that Arm has been working with the community to increase the footprint of software that runs on Arm is through our Works on Arm program. The Works on Arm program was created several years ago to establish free tools and resources for cloud-based developers to be able to access Arm-based compute. And what this has done is it's allowed a lot of the major open source programs to utilize Arm-based servers in their CI/CD process, therefore ensuring that Arm is a first-class citizen and is tested by all the major OSS projects. And we've now got support from all the major CI/CD vendors. So we're very excited that all of the cloud providers I spoke about earlier are now offering Works on Arm programs with free instance types to developers in some fashion. This will only continue to improve the quality of the software that can run on Arm compute instances. Now I want to shift gears a little bit and talk about some of the companies that have been public in their migration towards Arm-based compute and what's that meant to them. The first one I'll start with is Honeycomb.io. They were an early adopter of Arm Neoverse, and they've written an amazing and very detailed series of blogs about their experience moving their entire architecture stack from x86 to Arm. I encourage you all to check out their blogs. They are written from a developer audience perspective, but I've tried to summarize some of the highlights here. Honeycomb first moved their Shepherd ingest workload to Arm, to Graviton 2 specifically, and found that they needed 20% fewer instances and paid 10% less per instance to support the same workloads, a dramatic cost savings. They next moved their retriever workload to Arm that they found could scale up to 2x the number of threads without doubling their cost. And by this point, they had moved 92% of all their vCPUs to Arm. Next, they moved Kafka. And this was really about finding the right instance size to scale Kafka cost effectively. They ended up using the storage optimized Graviton instances. And the nice outcome here is that they gained another 6 to 12 months of growth capacity without increasing their instance fleet costs. Finally, they asked themselves the question, are we missing out by not considering a switch back to x86? And the answer was pretty resounding no. At this point, they've tested Graviton 3, seen a great performance uplift, and now there's no economic benefit moving back to x86. And lastly, they found that they could take advantage of the Lambda's invocation service and further see another 20% cost reduction on using the Lambda calls running on Graviton that had previously run on x86. Another company that made the switch to Arm was Databricks. Databricks achieved 3 to 4x better performance per dollar moving to AWS Graviton 2. And again, you can read more about this at the Databricks blog on the link below. Redpanda presents another interesting AWS customer use case. And this one is a little bit different because they're making use of the newer storage optimized instance family. And they also wrote a very interesting blog I call out here in the link below. But they also talked about how easy it was in terms of the experience of porting their code base, which are predominantly C++ based applications, over to Arm. There's often a perception that compiled codes are difficult to port. And at least for Redpanda, that definitely wasn't the case. A lot of this comes from the fact that Arm has been investing in compilers, low-level libraries, operating systems, and application-level code bases for many years. And this is where we'll dive in in more details in part 2 webinar that I spoke about, targeting the developer audience. Look out for that at the end of the presentation for more information. Now, not all these use cases are AWS-based Graviton use cases. We're also seeing very compelling use cases for customers that are adopting Microsoft's Azure VMs. Amadeus, a leading IT provider for the global travel industry, has been using Azure instance types in their public preview. And they've been able to see significant benefits as well. During their testing, they experienced an already mature ARM ecosystem, seamless integration with the Azure services, and high throughput and reduced energy consumption that came about through their use of the ARM-based VMs. Great experience so far with the Microsoft Azure rollout. Here's another example of ARM's leading power efficiency, this time from web infrastructure and security company Cloudflare. Cloudflare was an early adopter of ARM-based compute and has worked for the past 2 years on looking at their software stack and getting it optimized for ARM. The more recent announcements that they made around their adoption of the Ampere Ultra CPU as one of their top platforms for their next generation of infrastructure is actually the same Ampere Ultra CPU that's used by Oracle, Microsoft Azure, and Google. Cloudflare designs their own servers. And in their latest generation, they were able to demonstrate that these ARM-based servers can process 57% more internet requests per watt compared to their previous generation servers based on AMD EPYC Rome. Such a significant improvement in performance per watt is what really is driving Cloudflare to deploy ARM across their fleet. Now, Cloudflare can securely process over 10 times as many internet requests for every watt of power consumed versus servers that they had in deployment in 2013. Just a compelling improvement in performance that ARM has been able to deliver. And several companies rely on Cloudflare CDN and security infrastructure to power their websites across the globe. So next time that you're looking at some of your popular websites, don't be surprised if they were actually streaming from ARM-based servers in Cloudflare's infrastructure. Now, I couldn't resist including this tweet. This has been a long-standing argument that ARM could never penetrate the server market. But we proved we could build a core that goes head-to-head with the best from x86. And then AWS built Graviton around it. And the argument is largely new. So what's also interesting is that there are now a plethora of ARM-based developer systems. Now, this hasn't solved the problem that Liz points out here. But if you have a modern Mac, you're likely running on ARM. So from the developer community that's using the systems to design the apps, to the environments where those apps are deployed at scale, you now see a seamless ARM infrastructure at the heart of many of today's modern application deployments. So I'm assuming many of you are familiar with the technology adoption lifecycle. There are innovations and innovators and early adopters of the like. And as the technology matures, the number of companies that are able to take advantage of it increases. And what we're trying to show here is examples that help to prove that the market for ARM-based compute is now accessible to everyone. Whether it's through the options that you have in the public cloud, through the variety of workloads that run on ARM, or just by looking at what many of your colleagues at other companies have been able to accomplish with ARM-based instances, it's pretty compelling to now consider ARM as part of your IT strategy going forward. And from the standpoint of software just working and running performantly in the cloud, I'd say we're now there. Yes, there are still some enterprise long-tail applications that may need to be ported to ARM. But for the majority of cloud-based infrastructures, of cloud-native applications, there's no reason not to try ARM. And the ecosystem is now robust and continues to grow. With the Works on ARM program continuing to drive further open source projects and further investment in ARM, we see the ecosystem just continuing to evolve and become stronger and stronger. Therefore, I encourage everyone to take advantage, whether it's through a Works on ARM program or whether it's through lighting up your own instance types on any of the cloud providers I talked about today. And if you need further guidance, there will be a part 2 of a developer-focused deep dive on workload migration for Arm Neoverse. The title of that talk will be Frictionless Software Development on ARM-based Clouds. I encourage you to catch that session as well. Thank you for your time. Goodbye.